Well, good afternoon, everyone, and welcome to the Smoky Mountains Field School monthly webinar. The Smoky Mountain Field School is a 44-year partnership between the University of Tennessee and Great Smoky Mountains National Park. My name is Darren DeVault. I'm the director of University of Tennessee non-credit programs, the host organization for the Field School, and I'll be your host and moderator today. Our program is titled Research Conducted in the Smokies to Benefit Bat Management and Conservation. During this presentation, we'll consider the threats bat populations face and discuss research that has been conducted by the National Park Service and University of Tennessee to try and benefit imperiled bat species in the Smokies. We'll also take a look at several research projects that strive to understand bat ecology and behaviors and how they influence bat management and conservation. I'm delighted to introduce today's speaker, Dr. Emma Willcox, who is an associate professor in the University of Tennessee's Department of Forestry, Wildlife, and Fisheries. Following Emma's presentation, we'll wrap up with a Q&A session. You'll have an opportunity to ask a couple of follow-up questions of her. You can either ask the questions live or drop them in the chat, and I'll read them to her. So Emma, if you're ready, we'll turn it over to you. And welcome.
Great, thank you, and thanks for that introduction. I'm excited to have this opportunity to talk to you a little bit today about bats and some of the work we've been doing to assist with bat management and conservation in Great Smoky Mountains National Park. And I've got a series of slides here. A lot of them are photos. I like to just keep it kind of visual while I'm talking and just to illustrate some of the things I'm talking about. Some of the things, it's going to be a little kind of really just a very broad overview of the kind of things we're doing, but I'm certainly happy to go into more depth if anybody has any specific questions. So in the United States, we have approximately 47 species of bats. I say approximately, usually because at any one time there's potentially new species or there's discussions about how certain species have been classified. But of these, all but 3 of them are insectivorous species, and they're very important in terms of agricultural and forest pest suppression. So they provide a very important ecosystem service to us. The remaining 3 species are nectivorous, so they feed on nectar, and they're only found in the southwest of the country. So we don't have any of those in Tennessee. And they're found kind of in the area of around Arizona and places. That's the very northernmost part of their range. They're more common in Mexico and Central America. And these bats, obviously, in terms of ecosystem services, are important for pollination. But if we zoom in on Tennessee, the state is home to 16 bat species, all of which are quite small. The largest being the hoary bat, which is actually the bottom left picture there, that kind of really pretty kind of gray bat with a kind of bouffant hair style. It's actually one of my favorites, but it's the largest at about 25 grams or 0.9 ounces. And then the smallest bat is the tricolored bat at about 4.6 grams, so 0.1 ounces. Now the bats in Tennessee, they do vary in their morphology, so their appearance. They have some different face and ear shapes, different colors, and at least 2, the Raffinese big-eared bat and the Townsend's big-eared bat, as their name suggests, have these very large ears. And I was trying to bring my mouse back on my screen and it doesn't want to come at the moment. But you can see that Raffinese big-eared bat kind of right above the hoary bat on the left-hand side of this picture. There are a number of species in the genus Myotis, so that's the Indiana bat, the northern long-eared bat, the gray bat, eastern small-footed bat, and little brown bat that are much more similar in appearance to each other, and they really have to be carefully examined in their hand to successfully identify them. Now, of these 16 species that we find in Tennessee, 13 have been recorded as occurring in Great Smoky Mountains National Park. I've highlighted those in blue. You'll note that this includes the gray bat and the Indiana bat, both of which are listed as endangered by the US Fish and Wildlife Service. And they were listed a number of decades ago as a result of habitat loss, and particularly because they have a fairly limited range And they hibernate in a limited number of caves, and they were concerned that if these caves were lost, the species would be in serious jeopardy. More recently, the northern long-eared bat was listed as threatened, and this listing was a result of declines due to the disease white nose syndrome, which we'll talk about in a few minutes. But this species was once common in the park. More recently, the US Fish and Wildlife Service have also been petitioned to list the tricolored bat and little brown bat as either threatened or endangered due to white nose syndrome. And so a decision on that listing is still pending for these species. But again, both of these species were once very common in the park. Unfortunately, we know that bat populations face a variety of threats across the United States, from things like habitat loss, some of the things done to prevent that. You can see a cave gate there to prevent damage to cave hibernacula. Certainly we see mortality due to wind energy development. So a lot of bats are being killed by wind turbines. We also see issues with pollution. Certainly certain contaminants, things like mercury and microplastics, are thought that they may interact with white nose syndrome to kind of make the situation worse for bats. And so we're actually starting to study that in my lab. But also things like light pollution, which tends to influence bat behavior and affect some bats negatively. Then we have issues with climate change, and finally disease. And while all of these are very concerning and are resulting in population declines for certain species, of greatest concern currently for us is disease. And really one disease in particular, the disease white nose syndrome, which is caused by the fungus Pseudogymnoascus destructans. That's a bit of a mouthful. Unfortunately, the fungus doesn't have a common name. So you'll just hear me refer to it as PD, just to make my life a little bit easier. But PD was unknown to science until it was identified in 2008. And at that time, it was actually known as Geomyces destructans, but it's since been reclassified. Now, this fungus, as I said, causes white nose syndrome. And the characteristic signs of white nose syndrome is that white fungal growth on the muzzle of bats, as you can see in that right-hand picture. And also we see that growth occurring on the wings. Now, the exact mechanisms of the disease, how the disease works and its effects are quite complicated, but essentially the fungus invades the skin tissue, particularly on the wings, and it causes disruption of various metabolic processes. And so essentially it leads to dehydration and loss of energy reserves that are needed by the bat to survive. So it ultimately kills the bat, usually via starvation. And this all happens in winter when the bat is hibernating and when there is very little food available for them to rebuild those energy reserves and recover. Certainly, in addition to that white growth that we see, in the later stages of the disease, it's not unusual to see large holes in their wings where tissue has been destroyed. So this image on the left shows a bat wing under UV light, and areas where the PD fungus has invaded the wing tissue glows orange, and that tells us the animal has white nose syndrome. So it used to be that a bat would have to be sent for testing to know if it had the disease, but this is a very easy way for us to test for it in the field. Just really quickly, this is a map showing the spread of white nose syndrome. The disease was discovered in the winter of 2006, 2007 at Howell's Cave up there in New York. You can see that little circle up there. And since then, it's continued to spread rapidly up into Canada, down through the southeast, and now westward. And bats with white nose syndrome have been confirmed in 36 states and 7 Canadian provinces. So in 2016, it was actually found in Washington state. And you can see that's quite a jump from its previous range. And so likely it was moved there by people, which was how it actually likely got to New York in the first place. Anyhow, it was first detected in Tennessee in the winter of 2010, 2011, and then in the park in the Smokies shortly after. So I do want to mention at this point that white nose syndrome doesn't affect all species, rather just the cave hibernating species, so bats that spend the winter in caves in torpor. And Pseudogymnoascus destrucans is a psychrophilic fungus. It means it's cold loving, and its optimal growth temperature encompasses the temperatures that we find in winter bat hibernacular in those caves. So that explains why only certain species are affected. The cave hibernators, the fungus just really likes and grows well under those cold temperatures in the caves. So the list on the right, again, is the species of bat found in the Smokies, and those that are highlighted are those that are affected by white nose syndrome. All of the species in blue hibernate in caves, and all are common in the Smokies except the grey bat, which doesn't hibernate in the park and has only been caught twice actually by us near the park boundary. Some of the other species in the list can carry the fungus on their fur and skin, but to date, we've never seen them to become infected by white nose syndrome, so it's not having negative effects on them. I will say that white nose doesn't affect all of the species highlighted in blue the same. We have gone ahead, we have compared summer capture rates. This is the little chart on the left here, and winter counts of bats, both pre-white nose, so around 2002, 2004, and then post-white nose syndrome, so 2016. And we across the eastern US and in Great Smoky Mountains, we see that 4 species of bat are particularly affected by the disease. And that's the tricolored bat, little brown bat, northern long-eared bat, and the Indiana bat. So even though other species can get white nose syndrome, their populations don't seem to have been so badly affected. Now, populations of these species have really been decimated by the disease in the park. If we look at the summer capture rates, again on the left, you can see the declines in these 4 species from pre-white nose in yellow to post-white nose syndrome in blue. Like I said, these are capture rates, and it's kind of calculated by looking at number of net hours that we try to capture them for. And certainly, if we think of little brown bats and northern long-eared bats, which you can see are barely caught post-white nose syndrome, originally people would go out, you'd capture the species almost every night that you would net. Now we're lucky if we catch one netting for a whole summer. In terms of winter cave surveys, so where NPS personnel go in and count the number of each species hibernating in different caves, you can see in the little table on the right that declines have been large, ranging from 86 to 94%, depending on the species. Now, for something like the Indiana bat, the Smokies used to have the largest Indiana bat hibernacula in the state, so the largest number of Indiana bats. Now they just have a fraction of that number. The northern long-eared bats, not shown in this table, they're actually pretty hard to count in caves. They tend to hibernate in cracks and crevices where they're not easily seen, and not all of them spend the winter in caves, so it's hard to get a good handle on their numbers. But the good news is population seems to have stabilized, if there is good news, around these numbers, and we don't continue to see declines. As I mentioned previously, these species are all in various stages of listing as either endangered or threatened. So in terms of my lab's research in the Smokies, we have a variety of projects, but a lot of them focus on trying to help the park manage and conserve their remaining bats by conducting research on bat habitat. We seek to understand the different habitat requirements of different species. So in other words, what do they need for roosting? What do they need for food and foraging? What are their home ranges? What kind of space do they need to survive and reproduce? And if we can provide all of these habitat requirements, we hope that we'll be able to successfully kind of maintain the populations. For bats that survive white nose syndrome, what we call remnant populations, making sure we provide them with high quality habitat where they're able to survive and reproduce may be the key to their recovery. The problem is many of these bat species, particularly species like the little brown bat and tricolored bat, were once so common, no one did any research on them. And so we really don't know what they need. And this is often the case with common species. No one really studies them. Why study a common species? So now we're trying to play catch up and understand their habitat requirements so that US Fish and Wildlife Service, if they choose to list them, knows how to manage them. And this also applies to Great Smoky Mountains National Park personnel who want to try and make informed management decisions that are going to benefit the species. So before I summarize some of our research results, I wanted to give you just an idea of some of the techniques and methods we use to study bats in the Smokies. A lot of our research, but not all, requires us to first capture bats. For one study I'm going to talk about in a second, we were trying to understand why bats roosted in certain park buildings, and capture was relatively easy. We would just search a building, and when we found bats, like in this top left-hand picture up here, they're kind of snuggled behind a rafter in the roof. We would simply put a butterfly net over them and then capture them in that net. However, it's not normally that easy. Usually we have to capture bats in the park using what we call mist nets. And mist nets are fine mesh nets that we string up across either a cave entrance. Usually if we're using cave entrances, we're doing that during fall, spring, and winter when the bats are using the caves, either for hibernation or when they're preparing to enter or leave hibernation. However, in the summer and sometimes in the fall and spring, all 4 of our species of interest leave caves and roost on the landscape, usually in trees or buildings. And in this case, we string our nets up across what we term corridors. So for example, a road or a trail or stream cutting through the forest. And the bats fly along these corridors when moving across the landscape and foraging for food. They typically don't see, either by sight or echolocation, these nets as they are flying, and even if they do, they aren't able to avoid them in time. So they fly into them and become tangled. And we can then come in and gently remove them from the nets. And once we have them in hand, we can then identify them to species. We can determine their sex and reproductive condition. For example, are they pregnant or lactating? We can take their weight, and we collect any other samples that we might need. So hair and guano, which is feces, are common ones, and they're very useful to us. Hair, we can use for genetic analysis of species, if we're not sure. We can use it for mercury analysis. The guano, we can genetically analyze for diet, and we can also look at things like consumption of microplastics. And then at this point, depending on the study, the bat may be released. And so you can see the 2 pictures there on the right. The top is some folks stringing a mist net up across a corridor to catch bats, and then the bottom image is a cave where we're mist netting. And the little guy on the left there has been caught in the net, and we would come and remove him right away. However, I say we release a lot of them, but however, a lot of the research we do requires us to find where bats are roosting during fall, spring, and summer, or where they're foraging. And for us to do this, we have to attach a VHF radio transmitter to the bat before we release it. And this transmitter emits a pulse signal of a very specific frequency, which we can track using a radio receiver. And so we can track it about that across the park while it's foraging or to its roosting sites. Now the transmitter we attach is very small and only weighs about 0.3 grams, no more than 5% of the bat's body weight, to try and ensure it doesn't interfere with flight. And it's attached to the bat between its shoulder blades using surgical glue. And the battery in the transmitter only lasts about 20 days. And after that time, as the bat grooms itself, the surgical glue becomes weakened and the transmitter drops off. We track the bats usually initially in a vehicle. Sometimes we have to cover quite a large area before we pick up the bat's signal. Whoever that is, mute their microphone, please. Once we have found the signal, we then often have to continue tracking on foot as there are no roads to get us where the bats are located. Occasionally, we will have a pilot fly an aircraft over our study area to try and track a bat for us. This is most common when we're trying to track them when they're foraging and they're moving too fast for us to track them on the ground. I do just want to say here that bat radio transmitters aren't just used. We don't just use them to locate bats in the park. Some are temperature sensitive, and we have used them on bats that are hibernating to measure their skin temperature and see when they are in torpor and when they aren't. That's actually the image on the left there. You can see some bats hanging in the caves with transmitters. So when bats are in torpor, their skin temperature drops, and at the same time, the pulse rate of the transmitter also drops, and vice versa. So we record the pulse rate on a regular basis, and then we can use an equation that's provided to us to convert the pulse rate to temperature. Sorry about that noise in the background. I have a plane flying over. Another technique we have used to try and understand bat use of caves and their behavior during fall, winter, and spring are passive integrated transponder tags, PIT tags. And these are the same things that are implanted into your cat or dog's neck in case you lose them. And we implant the tags between, again, the shoulder blades of the bats. What we can then do is mount a large antenna around the cave entrance. And as those bats with PID tags fly past this antenna, it records the number on the PID tag. Each PID tag has a unique number. And we can look at the data recorded from that antenna and see when individual bats entered and exited the cave. And we can summarize how many bats are going in and out on a particular night, understand, timing of entry into and exit from hibernation. There's a whole wealth of things. And this technology is really relatively new in wildlife research, but it's starting to be used more these days for different species. And we're excited that we've had the opportunity to use it in the park. So for my last few slides, the result, I just want to present some kind of results for our research and how the park is using those results. So first, I'll just start with our study looking at bats in buildings in Great Smoky Mountains. I mentioned that we had been looking at bats in structures. And park personnel were first to understand what bats, wanted first to understand what bat species were roosting in buildings in Smokies, and second, why they might be roosting in these buildings. What was it about these structures that the bats were attracted to in terms of roost sites? And we call this selection. Why were bats selecting to roost in certain buildings over others? And did the buildings they selected have specific characteristics? If we can understand selection, we can often predict which buildings we might expect to find bats in and implement appropriate management. So the managers of the Smokies wanted this information for a variety of reasons. Firstly, they wanted to know if any white nose syndrome affected species might be roosting in buildings to determine if conservation measures needed to be implemented. Secondly, some of the buildings in the park were historic and under legal protection, and if bats were roosting in these buildings, what might they need to do to ensure the integrity of them, the buildings? Bats produce lots of guano and urine, which can cause damage, and how should they mitigate for that? And finally, wanted to know if there were situations where humans and bats might be coming in contact and there might be a public health risk. So we know bats do carry some diseases, including rabies, and managers were trying to think about that. So they were looking to balance all three of these things. So we surveyed 145 of the park's 500 buildings for bats. We found bats roosting in 44 of those buildings. You can see some images here of the bats. The one in the bottom middle there is actually a Rafinesque big-eared bat with a pup attached. So they were in 44 buildings. 16 of these were protected under the National Historic Register of Historic Places, and so might need some kind of protection, and 30 were accessed by the public. And the bats were comprised of 5 species. And if you look at that list, 2 of those are white nose affected species, which I've highlighted in blue again, the little brown bat and then the northern long-eared bat. In terms of selection, bats seem to select to roost in buildings that had low illumination. Certainly, that might be expected for a bat, it might make sense. So less light. And that also may be a sign that they have less disturbance in the buildings. There aren't lights and things going on and off. They also wanted buildings that were older than 10 years. And that's generally because those tended to have more cracks and crevices for roosting. And then finally, they wanted buildings that were farther from roads. And this last one takes a while to think about, but it likely again suggests that they like sites with less disturbance. If there are less roads, probably less people are visiting those buildings. So based on our findings, the park has proposed to restrict visitor access to certain buildings that may be important to bats affected by white nose and to prevent people coming in contact with bats. In other situations, it's been determined that bats should be excluded from buildings to protect their integrity. They also use this information to predict which buildings they might expect to find bats in rather than having to survey them all. We've also done a lot of work trying to understand the habitat requirement of the tricolored bat in the park. So that's that species that's being prepared, has been petitioned for federal listing. And a lot of this research is focused on summer and fall roosting. And so we wanted to understand more about where the species roost in summer and fall. We know they roost in trees, but which trees? And in fall, what proportion of their time are they roosting in trees versus caves? Fall is an unusual time for bats as they're feeding and preparing to enter hibernation, but they're also mating at cave entrances. We call this fall swarming. And so a lot of times they may be roosting in the caves. So this study is similar to the building one in that we're trying to understand which trees bats select to roost in and why. And this allows the park to ensure they're implementing appropriate things like prescribed fire management, hazard tree removal, all the things they do on a regular basis, to either maintain or enhance roost sites for the species. So again, in this case, we were tracking bats to their roost sites, usually trees. And then once we track them there, we have to find them in the tree to be sure that they're actually there. And that's what this image is trying to highlight. You can see here, this species typically is roosting in these leaf clumps. And so we have to spend a lot of time lying on our back with binoculars, searching the canopy to try and find that transmitter antenna there, which you can just see that faint white line sticking out. So it's very time consuming. Anyhow, we found that in summer and fall, they like to roost in oaks, in dead or living leaf clumps. They roost in trees that have high solar exposure, which likely means they're warmer and they could be important to bats in terms of their thermoregulation. The trees they select are usually surrounded by low clutter, so there are not lots of saplings and bushes growing around them, and this is likely important in creating a clear flight path for them. And the trees they select are also close to roads. And as I mentioned earlier, roads through the forest create corridors that many bats like to use to fly and forage along. So how is the park using this information? One of my grad students is currently helping them with a management plan for different bat species. And she is using this information to develop maps for the park of where the species is known to occur and could occur based on what we know about its roosting preferences. And this can then, they can use these maps as they plan their management activities. We're also now starting to look at tricolored foraging ecology, and this involves us tracking bats throughout the night by following those radio transmitters and determining each bat's location at regular intervals during the night, usually every 5 minutes via triangulation. And I don't have time to go into triangulation right now, but I'm happy to explain it later. And so we've been able to successfully track tricolored bats on the ground. We haven't had to use an aircraft. What this allows us to do is develop maps of home ranges for individual bats and to determine their core foraging ranges, where they spend most of their time foraging. And using these, we can explore the types of vegetation covers. Are they using more forest or open areas, or do they prefer to forage over water? And again, this can be used to help manage an area to maintain foraging areas for the species. Now, these maps aren't for the Smokies because we're still working on that, but on the left, you can see the home ranges of 5 bat species, five individual tricolored bats. And you can see one of them is quite large. That bat was actually flying about 15 miles one way each night to its foraging area. And then on the right, you can see the core foraging areas. I mentioned earlier we have to collect guano, and we've been using this to determine diet of bats at various times of year. This is actually from the winter. Again, this is important in terms of habitat management, and for bats recovering from white nose syndrome, understanding what they eat can provide a way for us to supplement their food sources in a variety of ways. This is kind of a complicated graphic, but it had some pretty colors. It's actually from a paper we're preparing, but just looking at kind of the types of arthropods or bugs different species of bats are consuming. And then the very last thing I just wanted to touch on is one of the ways in which we're using that data from the pit tags that we have implanted in a lot of bats. And we're using this data in a lot of ways, but one of these is understanding when different species, primarily Indiana bat and tricolored bat, are entering hibernation in the fall and are leaving hibernation in the spring. And the park was very interested in this for a few reasons. One is because they've considered putting buffers around caves during hibernation to prevent public access, so as to try and reduce disturbance to hibernating bats affected by white nose syndrome. And to do this, they need to know when hibernation occurs, but also some of their management activities, particularly prescribed fire, which is an important habitat management tool for bats and many other species, are restricted to when bats are in hibernation. And so these dates up to this point have been fairly arbitrary, and so they wanted a better idea of those dates so as to better position the window when they might implement management. So we looked at our pit tag data and essentially counted how many bats were detected by the pit tag reader at the cave entrance on each day of fall, winter, and spring. And then we used something called change point analysis to determine in the spring when there was a marked increase in the number of bats detected, indicating bats were leaving hibernation, and in fall a marked decrease in the number of bats detected on that pit tag reader, indicating the start of hibernation. And you can see the data there for the 2 species. I think I'm almost out of time, so I won't go into it too much, but you can see there we were able to get a very good idea of the timing of hibernation for each species. The Indiana bats tends to go into hibernation slightly later than the tricolored bat, but the tricolored bat emerges from hibernation slightly earlier than does the Indiana bat. And the park are using those dates to kind of rejig some of their application of things, like I said, like prescribed fire. So I think I'm pretty much out of time. I did just want to thank a lot of people from the Natural Park Service, the University of Tennessee. I also should mention, I should thank my father on here. He was very important, he's probably on this call, very important in helping us set up a lot of our electrical systems in terms of power and solar panels, so I always acknowledge him. People from Tennessee Wildlife Resources Agency, and then our funding sources. And so with that, I'm happy to answer any questions if I have time.
Okay, Emma, thank you. There's a question in the chat from Abe. Abe's 5-year-old son wants to know, or 5-year-old wants to know if bats eat spiders.
They do, yes, they absolutely do. Actually, that's something that it wasn't known really to what degree they did eat spiders. But some recent dietary analysis that's actually been done by some folks at Indiana University has found that yes, for certain species, spiders are quite a large component of their diet. And they don't catch those spiders on the wing, so they're not flying. They'll actually go down and they'll glean them, like take them off of leaves. So yes, they are important for consuming spiders.
If anyone has a question for Emma, please unmute yourself and ask her. Meanwhile, I'll ask you an easy question, Emma. What prompted your interest in bats and bat research?
Oh, that's a good question. Yeah, because until I moved to Tennessee, I actually didn't work on bats. I actually worked mostly on prescribed fire and its effects on birds. But when I got up here, somebody was doing some work on prescribed fire and was just curious as to what effect it might have on bats. So we actually did an acoustic project where we put out acoustic recorders, and we can use those to record bat calls and identify the species that are present. So we kind of were able to look at some of the effects of fire on what species were present in an area using that acoustics. And at that point, I think I just became hooked on bats. And so I've largely been working on them ever since. We have projects on some other mammals, but that was really what started my interest. And then I think with white nose syndrome and trying to conserve various species, it just became something that I was really passionate about working on.
Okay. Well, you mentioned that 16 different species of bats can be found in Tennessee.
Yeah.
And 13 of the 16 can be found within the Great Smoky Mountains National Park.
Yeah.
Do you have a particular affinity to any specific species?
I will say, I think most of my lab has become very fond of the tricolored bat. It's a very small bat, nothing particularly special about it, the way it looks or anything, but I think just it's been really hard hit by white nose syndrome. And so trying to understand how we can recover populations has become a passion for a lot of us in the lab. Other species, I like I said, I'm a huge fan of the hoary bat. Just it's a really cool looking bat, and we rarely ever catch them. And when we do, there's always a big fight over who's gonna get to handle it. So. Okay,
that sounds fun. What's coming up for you this summer? When you're not, are you teaching this summer? Or are you gonna do some interesting research?
I am not teaching this summer, except I do study abroad course, hopefully for a couple of weeks, depending on COVID. But other than that, I have a student that's working on the contaminant work in bats. So we're collecting fecal and hair samples to work on some of that. Also, I actually have some other projects that aren't bat related going on this summer with Appalachian cottontails and eastern spotted skunks. So we have some bat stuff and some not bat stuff happening.
Okay. Well, we really appreciate you sharing your time and expertise on bats today. We certainly wish you well with your future research and may want to catch up with you in the future.
Oh, yes. And anytime. I'm happy to answer any questions.
That sounds great. Thanks for everyone for joining us. The Smoky Mountain Field School, in addition to its new monthly webinar series, we have live programs generally held on Saturdays for your convenience. And our upcoming opportunities can be found on our website at utnon-credit.com. Again, utnon-credit.com for future Smoky Mountain Field School programs. Want to certainly thank Lydia Humphrey, one of my teammates at UT Non-Credit Programs, for her valuable assistance today and the production of today's webinar. So we hope to see you guys next month, and thanks for joining us today. Goodbye.